Hi, today we're going to do Unit 5, Lesson 5. We're going to be finding lengths of arcs on a circle, and we're going to be finding areas of sectors of a circle. We're going to be starting with lengths of arcs. And so an arc is basically part of the circumference of a circle. On this particular circle, S is an arc. You can also think of it as arc AB. So S is really the same as arc AB. And to find the length of an arc, you're finding part of the circumference. And we did some of this in geometry a couple of years ago. We called the length of the arc L then. It was like a cursive lowercase l. In Trig, we're going to call it S. So to find S, you're going to take the central angle, which in this case is theta. Theta divided by 360 times 2 times pi times r. Now 2 pi r really is the circumference of a circle. That's the formula to find the circumference of a circle. So when we do theta divided by 360, we're taking that many degrees out of 360 of the circumference. So we're taking a portion of the circumference. This is the formula that you could use to find the length of an arc if you're given the angle, the central angle of the circle in degrees. If you're given your central angle in radians to find the length of the arc that angle opens up to, you can actually just take theta times r. I'll show you why that is. So if you're given your measurement in degrees, to find S, or the arc length, you would take theta divided by 360 times 2 times pi times r. But remember, to convert to radians, you multiply by 180 over pi. So if I simplify my equation, the pi's can cancel out. 2 times 180 is 360, so the 180 and the 2 can cancel out with the 360, and we're left with the arc length being theta times r. So as you can see, this is a great formula to use if you're given your central angle in radians. Let's try example 1, part A. So it looks to me like we're given the measure of angle AOB, which is this little angle right inside of here. And we are going to find the length of arc S. So S should equal 130 degrees out of 360 times 2 times pi times the radius, which is 8. You would take your calculator, you would type all that in. You might have to put the 130 divided by 360 in parentheses. And when you type that in, you should get 18.151. And we'll just say units since it's not really marked what we're measuring in. Why don't you take a minute and see if you can do part B. If you did part B correctly, you should have done 210 divided by 360 times 2 times pi times 8. And when you type that in, you should get 29.322 units. So next you can see we are given an angle measure in radians. You can see the measure of angle AOB is 2 pi over 3. Which is about 120 degrees, I believe. But we could convert it to degrees, or we could just use our length of a arc formula for radians, which is theta times r. And in this case, we're just going to take 2 pi divided by 3 times 7. And we can, again, go ahead and just type that in our calculator if we want an approximate length. And if we do that, we should get 14.661 units in length for the length of this arc from A to B. Part D, find the length of an arc that subtends a central angle of pi over 6 in a circle of radius 3 miles. So when it says subtends a central angle, it really means you have a circle, the angle opening up to the arc we're looking for, we'll call this S. This angle right in here is pi over 6. It opens up to that arc S, and we have a radius of 3 miles. So again, we're given our measurement in radians. We should be able to just take theta times r. So we're going to take pi over 6 times 3. This ends up being pi over 2. Whoops. Or if you type it in your calculator, it's about 1.571 miles. We can also work backwards. Given an arc length, we can work backwards and find the central angle that opens up to that arc length. So in this case, they want us to find theta in degrees. So our arc length can be theta over 360 times 2 times pi times r. So if we fill in our values, 14 is our sector. Theta we don't know. We do know 2 is 2 and pi is pi, and our radius is 6. So you have to do a little bit of working backwards. I would probably take 14 and divide by 12 pi. When you do that, you're going to have to take 14 parenthesis 12 divided by pi. You'll wind up with 0.3714, equals theta over 360. And then you can multiply by 360 on both sides. That should give you theta is 133.690 degrees, the measure of that angle. Go ahead and try part B. If you did part B correctly, you would set it up 7 equals theta over 360 times 2 times pi times 4. Take 7 and divide it by 8 pi, and you should get 2.2785 equals theta over 360. Multiply both sides by 360, and theta comes out to be 100.268 degrees. In this next example, we're going to solve for degrees and radians, but really we do it the same way. You have a central angle in a circle. It has a radius of 2 meters, and the central angle is subtended by an arc length of 12 meters. So this arc length is 12 meters, and they want us to find theta, that angle, in degrees and radians. So a couple ways you could do it. You could say the length of the arc, S, is x over 360, 2 pi r, or theta over 360, 2 pi r. And go ahead and plug in your numbers. So you could have 12 equals theta over 360 times 2 times pi times 2. Take 12 and divide it by 4 pi. You probably have to put this in parentheses in your calculator. And then take that answer, which is 0.9549, and multiply both sides by 360. Theta should turn out to be 343 degrees, 0.775. Apparently, I did not even come close to drawing my picture to scale. That's a really huge angle. It's almost all the way around the circle. If we wanted to convert this to radians, a quick way to do it is just take our 343. So we take our 343.775 and multiply by pi over 180. And that will do a quick conversion to radians. And it's kind of crazy. Turns out to be 6 radians. Now you could have done that in reverse. If you wanted to, you could have solved for radians first and then converted to degrees. That way works as well. Okay, so same idea, but this time we are given the length of the arc and the angle measure, and we're going to be solving for the radius. So think about your formula for the length of an arc if you're given your angle in radians. So the length of the arc equals the radians times the radius, or the angle times the radius. Let's fill in what we know. So our arc length is 10. Our theta is 2 radians, which, remember, each radian is about 57 degrees, so that's about a 114 degree angle, but we're dealing with radians. And then we want to solve for r. All you have to do, divide by 2. Your radius is 5 units. Let's try one more of those. So in this case, we're given the arc length, and we are given the angle that opens up to that arc, and we are supposed to find the radius. So the arc length will equal theta times r. 15 equals 2/3 pi times r. Multiply by 3 over 2 pi on both sides. Here we're going to cancel. We'll be left with r. And on this side we're going to have 45 divided by 2 pi, which you can type into your calculator. And the radius is approximately 7.162 units. go ahead and try example 3. It's just like the last two. I'll give you a second. Go ahead and pause. If you did it correctly, the radius should be 1.273 feet. Okay, so in addition to working with lengths of arcs and circles, today we're also going to be finding areas of sectors of circles. Now this shaded in little piece of pie here is a sector of the circle. And to find an area of a circle, it's pi r squared. So if we want to only find part of a circle, we're going to take the degree measure, which in this case would be theta, divided by 360 times pi r squared. It's going to give us a certain number of degrees out of 360 times the area of the circle. So this is if you're working in degrees, or if you want to find your area based on radians, your formula is actually 1/2 theta r squared. How does that work? I'll show you real quick. If you start out with your degree formula, which is theta over 360 times pi r squared, and we convert to radians, we would have to multiply by 180 over pi. So cancel out. You can see we can cancel out the pi's. 180 into 360 goes in twice. So what do we have left? We have theta over 2 r squared, which is the same as 1/2 theta r squared. So again, this is if you're dealing in radians. So let's find the area of the shaded sector of this circle. I notice that I'm given my angle in degrees. So for me personally, I usually tend to just use the degree formula, which is going to be 135 out of 360 times pi times 14 squared. If you'd rather convert 135 into radians and use the radians formula, that's totally fine. You then can type that into your calculator and get the final answer. After typing it into my calculator, I see the answer for the area of the sector is 230.907 meters squared. Let's try part B. Find the area of the sector of a circle with a central angle of pi over 3. Pi over 3, I don't know if you remember this, it's 60 degrees. So it'd look about that big. So that is pi over 3. And the radius is 3. And we want to find the area inside of this piece of pie here, this sector. So this time, since we're given our measure in radians, I could convert it to degrees if I want. Or I can just say, oh, in radians, it's 1/2 theta r squared. So I know our theta is pi over 3, so 1/2 times pi over 3 times 3 squared. This reduces to pi over 6 times 9, which is 3 pi over 2, or as a decimal, it is approximately 4.712 meters squared. All right, so this last page, go ahead, it's your turn. Give these a try. Push pause, and then when you're done, check your answers. I'll put them up on the screen. Okay, check your answers, see how you did. Probably the one that might have been confusing is number 2. For that one, I said, okay, the length of the arc equals theta times the radius. So I did 8 equals theta times 10, divided both sides by 10, and I got theta equals 0.8 radians. Well, it wants the answer in degrees, and so you have to multiply by 180 over pi. And it turns out to be about 45.837. All right, good luck. Try the 5.5 homework, and we'll see you next time.